Ah, the unit circle. I know, for a lot of people, this is one of the most intimidating topics in pre-calculus. But what if I told you that you could conquer this entire thing by just mastering one tiny little piece of it? Well, let's dive in and see exactly how to do that.
And that right there, that's the big promise. So forget about trying to cram dozens of coordinates into your brain with brute force memorization. The entire unit circle is just built on patterns and symmetry, and we're going to unlock it with one simple, super powerful strategy.
That's right. The whole concept, this giant, scary circle, it all comes down to a foundation you probably already built way back in geometry. So see, we're not even learning something totally new here. We're just applying what you already know in a much more powerful way. Okay, so take a good look at this slide because this is it. This is the golden key. This tiny little table is the only part of the unit circle that you have to flat out memorize. That's the x values, the cosine, and the y values, the sine, for just these three key angles. Get this down, and I promise you're already halfway there. Okay, so we've got the numbers, but how do we know if they're supposed to be positive or negative? Well, that is where our golden rule comes in. It's a super simple mnemonic that gets you the correct sign every single time.
All students take calculus, ASTC. You've probably heard it before. Starting in that top right quadrant, quadrant I, and moving counterclockwise, this little phrase tells you which trig functions are positive. So in quadrant 1, all of them are. In quadrant 2, just sine. Down in quadrant 3, it's tangent. And over in 4, it's cosine. This is the system that runs the whole show.
All right, theory time is over. We've got our values from quadrant 1 and our ASTC rule for all the signs. Now, let's put them together and actually see how this whole bow tie method works in practice. So let's try sine of 150 degrees. First step, find the reference angle. That's just the shortest path back to the horizontal x-axis. From 150, it's a quick 30-degree jump to get to 180, right? So we know our answer is going to have the same value as sine of 30. Step 2, check the sign. 150 degrees is in quadrant 2. According to ASTC, S, sine is positive there. So sine of 150 is just positive sine of 30, which we memorized is 1/2. See? Simple as that. Now for radians, don't let them scare you. Let's find the cosine of 5 pi over 3. The secret here is just to look at the denominator. If it's a 3, that means the reference angle belongs to the pi over 3 family. Now, where is 5 pi over 3? Well, 6 pi over 3 would be a full circle, so we're just a little bit short of that, which puts us squarely in quadrant 4. And our rule, CST, tells us cosine is positive there. So our answer is just the positive value of cosine of pi over 3, which is, again, 1/2. Okay, what if they throw a curveball, like a negative angle? Let's do tangent of negative 3 pi over 4. A negative angle is no big deal. It just means we rotate clockwise instead of counterclockwise. When we do that, we land in quadrant 3. Our reference angle family here is pi over 4. So what does ASTC say about quadrant 3? Tangent is positive. That means tan of negative 3 pi over 4 is the exact same thing as tan of pi over 4, which is just 1. You're doing great. You've got the system down. Now let's just talk about the one common mistake that trips up almost everybody, just so you can sidestep it completely. It all comes down to mixing up the values for 30 and 60 degrees. It's so easy to forget if the square root of 3 over 2 goes with sine or cosine. But here's the trick. Just picture the angle. A 30-degree angle is really shallow, right? It goes out horizontally way more than it goes up vertically. A big horizontal distance means a big x value, which is cosine. So cos 30 is the big number, root 3 over 2, and a 60-degree angle, that's steep. It has a much smaller x value, which is the 1/2. So at this point, you're probably thinking, okay, this is a neat trick, but why do I actually need to know this? And that's a totally fair question. But mastering this stuff isn't just about passing a test. It's a really fundamental skill that, believe it or not, shows up everywhere. I'm serious, this skill is absolutely critical. Once you get to calculus, you're going to need to evaluate these things instantly to solve much bigger problems with limits and integrals. Engineers use these exact same principles to figure out how to design bridges that don't fall down. And it's even in nature. You know the perfect hexagonal shape of a honeycomb? That's built on the very same 30, 60, 90 triangles that are at the absolute heart of the unit circle. So think about what we just did. By memorizing one small quadrant and one simple rule, you've basically gained the power to solve an infinite number of problems all the way around the circle. You haven't just learned a topic, You've unlocked a fundamental tool for making sense of the world. So the only question left is, what are you going to solve with it next?